Hello guys, how you doing? How you doing? How you doing? Good to see everyone once again. Welcome back to our lecture, to our video today regarding a review for test number 5. So, the semester is coming to an end. You're almost there. Test 5 is upon us. So let's go ahead and look at our review for test number 5. All the questions in the review that I emailed to you will not be assessed. Some of them will. The ones that you will be assessed on, I will go over those type of questions, plus a few additional questions, okay? So let's go ahead and let's get started. Alright, so here we go. Number 1, let's evaluate log base 4 of 4 to the 1/4. The base of the log cancels the base of the exponent, and we're left simply with an answer of 1/4. That's done. Alright, here we have log base 5 of 1/25 equals x. And I would do the wheels on the bus in this case. So I would take it and start here with 5. 5 to the power of x equals 1/25. Wheels on the bus, go around. So we have 5 to the power of x equals 1/25. Okay, so far so good. Alright, now work on this. Work on 1 to the 1/25. Work on that. Why don't you rewrite that? Alright, and if I rewrite it, that's going to give me 5 to the power of x equals 1/5 squared, because 25 is 5 squared. Alright, continue to work with it. Rewrite it again. Alright, let's rewrite it right here. So we're going to have 5 to the power of x equals, now 1 divided by 5 squared can be written as 5 to the -2. And there you go. Once you have the same base, they cancel. So we're going to simply have x equals -2. And we're done. Okay? So 1/25 can be rewritten as 1/5 squared, because 5 squared is 25. And then 1 divided by 5 squared can be rewritten as 5 to the -2. And so now we have like bases here. 5 to the x equals 5 to the -2, right? So since the bases are alike, cancel the bases out, so x equals -2, and that's our answer. Okay. Next problem. Is the graph 1 to 1? Well, let's see. Let's use the horizontal line test, the HLT, to determine whether or not it's 1 to 1. So draw horizontal lines. If I draw a horizontal line here, one touch, one touch, one touch, one touch. So this is yes, yes. The graph is 1 to 1. Because for every one horizontal line, there's only one point of intersection for each horizontal line. They're not more than one. Okay, so it is 1 to 1, absolutely. Alright, now let's see what's happening over here with question number, and by the way, this is question number 1, number 5, number 6. Omit question number 2, question number 3, question number 4. Please omit them. If I do not cover them or go over them, then omit them. Okay? So now we're on question number 7. F of x is negative root of 6 minus x, and g of x is 5 minus x. Find g minus f of x. Okay. So what is g? G is 5 minus x. So it's g minus, and what is f? F is negative square root of 6 minus x. Alright, which equals All right. What you have to recognize here is that a negative times a negative is a positive. So it's going to equal, here we go, 5 minus x plus the square root of 6 minus x. And we'll stop right there. All right. State the domain of this in interval notation. All right. Well, the only restriction or the only issue we may have with the domain is by the argument that's contained inside of the radical. So the argument that's contained inside of the radical has to be greater than or equal to 0. Has to be those positive values or 0 itself. Other than that, you would get imaginary numbers, which is beyond the scope of the class right now. We're not doing imaginary numbers. So the argument in this case, so to answer this one, we answer this question, we have to consider the argument right here. And the argument is 6 minus x. So you take your argument, 6 minus x, and you set it greater than or equal to 0. And you have to solve that. You have to solve that. So we have 6 minus x has to be greater than or equal to 0. Okay, let's go ahead and solve this now. All right, to solve it, to find the our interval notation that satisfy all of these x's in our radical, let's first go ahead and subtract 6 from both sides. If I subtract 6, I'm going to get negative x is greater than or equal to a negative 6. All right. Well, if negative x is greater than or equal to negative 6, now I have to divide both sides of my inequality by negative 1. Here's where you have to be very careful when you divide by negative 1. When you divide by negative, you have to switch the direction of the sign. It goes like that now. When you divide by negative. When you divide by negative or multiply by negative, change the direction of the inequality symbol. That's critical and highly important. All right, so a negative divided by negative is a positive, and a negative divided by negative is a positive. All right, there we go. All right, this is our algebraic notation. But they want what? We need to express this not in algebraic notation. We need interval notation. Interval notation. All right, so x is less than or equal to 6. So this arrow, if I make this an arrow, the arrow is pointing to the left. See that? That's pointing left. All right, so interval notation, we have to start at 6, bracket, put a bracket on the 6, because it's less than or equal to, and now go to the left of 6, which is going to take us all the way to negative infinity. And you put parentheses on infinity. So that's our interval notation right there. That is interval notation. All right. So we go from negative infinity all the way to 6. That is interval notation, from negative infinity to 6. Okay? That's done. All right? Find the inverse of f of x. All right. For number 8, in your review, let's see, because you don't have this problem, but I want you to change number 8 to this problem. Make that number 8. Let me see what do you have. Yes, for number 8, I think you have 7x plus 1. For number 8, here's what you have. F of x equals 7x plus 1. Erase that one. Take it out. Do this one. F of x equals 8 divided by x minus 3. Alright, so if we want to find the inverse, the first thing we have to do is write this as y equal 8 over x minus 3. Alright, so take this f of x and write it as y. Step 2, interchange x and y. Okay, so where the x is, you write the y. Where the y is, you write an x. Let's interchange x and y. So we're going to have x equal y. No, x equal 8 divided by y minus 3. Good. Now solve for y. That's the big step right there. Solve for y. In other words, y equals what? What is y equal? Because right now you have x equal. That's not what we want. We want to know what does y equal. So let's solve that for y. So in doing that, we're going to have x equal 8 divided by y minus 3. We're going to go ahead and add 3 to both sides. Add 3 to the right, add 3 to the left. We're going to get x plus 3 equals 8 divided by y. Not bad, not bad. And then what we want to do, let's go ahead and let's switch the x plus 3 and the y locations. So let's write the 8 divided by y first equals x plus 3. Let's do that. Alright. Now, since this is really x plus 3 and it's over 1, let's go ahead and take the reciprocal of both sides. That still preserves the equality, right? Let's look at y over 8. Y over 8. See, that's the reciprocal. 8 over y is y over 8. Take the reciprocal right here. This is going to be 1 over x plus 3. So take the reciprocal of both sides. Alright, and so we have y over 8 equals 1 over x plus 3. And we mentioned a long time ago, if you want to get rid of a fraction, the most important thing is to multiply both sides of the equation by the number that's in the denominator, because it's the number in the denominator that really upholds the fraction. Everything is built on that. So if I were to multiply both sides now, so if I have y over 8 equals 1 over x plus 3, if I were to multiply this side and this side by 8, because that's what holds up our fraction here, cancels out. So I have y now equals 8 over x plus 3. And that's what I have done. I have solved it for y. And that's pretty much our inverse right there. So now take out the y and use inverse notation. So what can we say? F inverse of x equals 8 over x plus 3. Alright, there you have it. This is the inverse. That's how we go from here to there. That's the inverse. Alright, f of x equals x squared minus 14x plus 49, and g of x is x minus 7. Find f divided by g of x, then state the domain. Alright, so notice this. And my numerator is f. So that's going to be, alright, so we're going to have f divided by g of x is going to equal f, which is x squared minus 14x plus 49, all divided by x minus 7. Okay? So now, let's state the domain. Alright, the domain. Well, let me see here. X can be any value, but what is the restriction? So the question is, what is the restriction? In other words, what can my denominator be? What causes the denominator to be undefined? Well, my restriction is that x cannot equal 7. So my domain in interval notation is, here we go, it's going to go from negative infinity over to 7, union 7 to positive infinity. Alright, that's the domain. This is my domain. It's from negative infinity over to 7, union 7 to positive infinity. Not bracket. No bracket. Okay? Because you can't include 7, because 7 actually makes our denominator 0. It's undefined. Alright, number 11. Let's form f of g of x, which is the same thing as, here we go, this can be rewritten as f of g of x. Alright, so you want to put g inside of f, and this can be also written as g of f of x. So let's go ahead and put g inside of f. Alright, so then we're going to have, let me see, what is f? Well, we're going to have f evaluated at, alright, and what is g? G is 6x squared plus 5. So put 6x squared plus 5 inside of f. So that's going to equal 5 times 6x squared plus 5 minus 3. I have just placed g inside of f. Now let's simplify it. So it's going to equal 30 x squared plus 25 minus 3, which is going to give me 30 x squared plus 22. And that's going to do it. That's it. Alright. And so now we want the golf. We did the fog, right, F-O-G, which is F composition of G of X. Now I want the golf. I want G composed of F with respect to X. Alright, so going after the golf, I think I'm going to erase some of this now. I need more board here. Alright, let's do the golf now. The golf says that G of, or what is F? F is 5x minus 3. And what does that equal? Alright, let me see here now. So where's my G? 6. Alright. Times 5x minus 3. There it is. Quantity squared plus 5. Now in this case there's a lot of work you have to do in terms of breaking it down and in terms of multiplying and foiling of that nature. So So here we go. It's going to be 6 times 5x minus 3 times 5x minus 3 plus 5. You have to write it twice because it's 5x minus 3, 5x minus 3. It's 5x minus 3 quantity in the square, so write it twice. Alright, and this is going to equal 6 times, alright, we're going to have 25x squared minus 30x plus 9 plus 5. So you may be wondering, well, where did you get this from? Oh, my goodness, where did that come from? That's the foiling method. We talked about that some chapters back in FOIL. Right? You take the first 5x times 5x, and then you take 5x times 3. Well, in this case, it's a minus 3. 5x times a minus 3 is a minus 15. Then you come back in and look at negative 3 times 5x, and then negative 3 times negative 3, which is positive 9. So it's basically a foiling technique that you have to do. Okay? So what is this going to equal? Equals. So now you take 6 and distribute it. 6 times 25x squared. Well, that's going to be 150 x squared, and then 6 times 30, negative 30, that's going to be minus 180. And then 6 times 9, that's going to be plus 54, plus 5, which in essence is going to give us 150 x squared minus 180x plus 59. Alright, there we go. That got it. So that's what g of 5x minus 3 equals. 150x squared minus 180x plus 59. Okay, that's number 11. Alright, let's go back to the worksheet here. Let's go back to our review. We made some changes and we modified just a few things. We did 11. Alright, number 12. What do we have? Log base 4 of 4 log of 16, and all this equals x. Log base 4 of 4 to the log base 4 of 16. Alright, so as we started out with number 1, do the same thing here. Log base 4 and the 4 exponent cancels out. The base of the log and the base of the exponential portion of it cancels. So in essence, I'm going to have log base 4 of 16 equals x, and then do wheels on the bus that go round and round. Because the wheels on the bus go round and round, round and round, round and round. So 4 to the power of x equals 16. Just go around, make a circle. So 4 to the power of x equals 16. And we said always break down the bigger number. Break down 16. What is 16? That's 4 times what? 4. Okay, stop right there. So bring down 4 to the x and have that equal, well, how many 4s are here? 2 of them. 4 squared. And there you go. Because here the 4's cancel, and so x equals 2 is your answer. And that's going to do it for number 12. Yay! That's not too bad. Now remember, ladies and gentlemen, if you have to, you can like stop the video, pause the video. You can like rewind the video or fast forward the video, whatever you need to do. Okay, to kind of help you along the way here. Okay? Whatever you need to do. Alright, that's number 12. Let's see here. 13. Okay, for number 13, I'm not going to draw the graph, I'm not going to draw the picture. I'm going to recommend that you go back and refer to the lesson for number 13. I believe this was lesson 8.4, no, 8.3. I think it was 8.3. So go back and refer to lesson 8.3 regarding question number 13. Okay? All right. 14's a skip, 15's a skip, 16's a skip, 17. For question number 17, you literally have to select the correct graph. So use your graphing calculator for number 17. Put the equation into your calculator and see which one matches. So for number 17, that's the whole purpose for having the graphing calculator, is to use it. So put the equation in and see which one it matches. In fact, I think it's the last one to the far right. Well, I don't think, I know it is. It's the last one to the far right. Okay. And number 18, 19, and 20, okay, is using the graphing calculator. All right. So I'm not going to, necessarily do it, but I'm going to show you what to do. So for number 18, you have f of 3.5. Well, let me start like this. F of t equal 9.1 times e to the negative 0.04t, right, when t equals 3.5. So that's just a direct, direct substitute. Plug in 3.5 for t. Which means then that f of 3.5 is going to equal 99.1 e to the negative 0.04 times 3.5. And there you go. Please plug that into your calculator, right? And round to the nearest hundredth. To the nearest hundredth. That's important. The nearest hundredth. All right? That's important. Round to the nearest hundredth. All right, so for example, if you got 0.4531, what's the nearest hundredth here? Okay, compared to, for another example, what if I had 0.4572? If I round this to the nearest hundredth, right? Well, here's the units column, tenths, hundredths. Here's my hundredths column, hundredths. But what I do with this 5 is predicated upon the number to the left of it, 3. 3 says leave the 5 right where it is. So if I take it and if I round to the nearest hundredths right here, my answer is going to be 0.45. That is rounded to the nearest hundredths. But in this case, we got that same 5 right here. Now if I were to take this and round this to the nearest hundredths, well, this 7 tells me to take this 5 up to 6. So that's going to be 0.46 hundredths. So it's not the same answer. There are different answers here, but it's according to rounding to the nearest hundredth. That's very important. If your rounding is off, your answer will be incorrect. Your rounding must be correct. All right? So that's direct plug-in, direct substitution. Number 19 is somewhat similar to this, number 19. It's also like a direct substitution, but it's using the compound interest formula. So for number 19, we have A equals P times 1 plus R over N to the power of N times T. And they give you some things. P is 9,500. R is 9%. N is quarterly. And time is 16 years. Alright guys, there you go. Just substitute. Be careful here because we're going to have actually A, it does equal P, 9,500, times 1 plus. Now the R right here, you can't put it in as 9%. You must write this as a decimal. Right? Which is going to be 0.09. That's a must. Okay? So we're going to have 0.09 divided by quarterly. This means N equals 4. To the power of N, which is 4, times time is 16. Ladies and gentlemen, please, if you're going to use, I would recommend you use your graphing calculator to like calculate these. Notice this, okay? Notice here I have, look, 1 open parenthesis, 2 open parentheses, and I have 1 closed parenthesis and another closed parenthesis. For every open parenthesis, I have a closed parenthesis. They must match. Open parenthesis, closed parenthesis. If you put it in the calculator just like this, you'll be fine. In this case, also round to the nearest hundredth. Why? Because this is talking about money. You know? And the nearest hundredth represent change, cents. 50 cents. You know, 30 cents, 23 cents, etc., etc., etc. So that's calculator as well. And the same with number 20. 20 is also direct substitution. Plug it right in. Alright? We have C of T. That equals 0.08 times 1 minus e to the negative 0.2t when t equals 5 minutes. When t is 5 minutes, and this time round to 3 decimal places. Round to 3 decimal places. Now, 3 decimal places is not like hundreds, because hundreds is 2 decimal places. Alright? 3 decimal places is thousandths. Thousandths. But it's the same concept of rounding to 2 decimal places. It's just thousandths. Okay? Okie dokie. Now let me see here. Let's just do a few more log problems. Let's do some additional log problems, and that's going to do it, okay? I want to do some additional logs. The calculator stuff you can do. Let's do some additional logs. Okay, which is, I'm going to call it number 21. See if you can do these. 21. What about the log base 7 of 7 to the negative 2 equals x? Alright, you already know what to do. You already know what to do. Log base 7, the base of the log, and the base of the exponential base 7 cancels, and there's your answer. X equals negative 2. Alright, 22. Let's just get some more practice in. 22. What if we have log base 10 of 100 equals x? So many ways to do these problems, right? There are a plethora of ways. If you're familiar with wheels on the bus and you feel safe with wheels on the bus technique, use the wheel on the bus technique to evaluate or to solve this for x. Wheels on the bus says take the base and make a circle. Starting from the base, go around, make a wheel. So it's going to be 10 to the power of x equals 100. 10 to the power of x equals 10 squared, because 100 is 10 squared. Okay, so 1 and 2 zeros. And so the 10s cancel out, and so x has to equal 2. We're done with that. Or you could have worked it out like this. You could have said log to the base 10 of 100 equals x. Log to the base 10 of 10 squared equals x. And log base 10 cancels out the 10. And you get x equals 2 also. Either way works. Either way. Alright. Let's see here. What about, let's do another one, 23. What if we get log base 3 of 27 equals x? In this case, you can do it either way again. This is this. 23 is 22 in essence. Right? If you feel comfortable, wheels on the bus, do wheels on the bus. 3 to the power of x equals 27. 3 to the power of x equals 3 to the power of 3. That's what 27 is. So x equals 3. Or you could have written it like this. You could have said log base 3 of 3 to the power of 3 equals x. Because 3 to the power of 3 is 27. So log base 3 cancels out the base of our exponent, which is 3. And so x has to equal 3. You can go about it that way. Okay. Yep, I think that's about going to do it. Let's see, 24. Let's look at a couple more. Let's look at 2 more. Let's look at 2 more. 24. How about log base 81 of 9 equals x? Wheels on the bus. Take it around. Alright, there and there. So 81 to the power of x equals 9. Remember, you always take the larger number and try to break it down to the smaller number, right? The larger number up here is 81. So let me break down 81. Alright, so I know I can take 81 and break it down. 81 is what? 9 times what? 9. 9 times 9 is 81. Alright, I can put this here and bring down that x. Bring down that x. 9 times 9 is 81. So 81 to the x is 9 times 9 to the x. How many 9s is this? How many of them are there? How many 9s are present? 2 of them. So this means that we're going to have 9 squared. Bring down the x. All right? And then what we do, we multiply these two things. We multiply the 2 times the x. So the 2 times the x has to be multiplied. And so in essence, we're going to have 9 to the 2x. Got it. And that's all on this one side. Equal, equal, equal. Bring the 9 straight down. So this 9 just keeps coming down. And so now we have the same base. And bear in mind, this is a power of 1 right here. Power 1. So this 9 cancels this 9, and we're going to have 2x equals 1. Two x equals 1. Divide both sides by 2. The 2's cancel out. So x has to equal 1/2. All right. Good. Good, 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 good. X has to equal 1/2. Let's see, do I have another one? Yes, do one more. One more. And then I'll be done. One more. 25. Let's look at log base 8 of x equals negative 2/3. Wheels on the bus. So we're going to have 8 to the power of this equals x. All right. So here we go. 8 to the power of negative 2/3 equals x. The good thing is if you have a graphing calculator, calculator will do all these calculations for you. So you want to put 8, I'll put parentheses around my exponents. 8 to the power of negative 2/3, get an answer, and then go to math, enter, enter, and you have it. If you do not have a graphing calculator and you have to work it by hand, but then you come on and work with me. I'm going to show you what to do. Since my exponential power is negative, that means I have to take the argument, which is 8 over 1, and reciprocate it. So it's going to be 1 divided by 8, and now it's to the positive 2/3. Reciprocate the argument whenever the exponential power is negative, and we did that, so we get 1/8 to the power of 2/3. Well, power 2/3 can be written as a radical, because right now it's a rational exponent. 2/3 is a rational exponent. So take your rational exponent and write it as a radical. So this is going to give me, and this of course still equals x, so this is going to give me the cube root of 1/8 quantity squared equals x. See that? I've written my rational exponent now as a radical. There's a 3, there's a 2. Where's my eraser? All right. So x is going to equal. Well, what is the cube root of 1/8? Well, that's the cube root of 1 divided by the cube root of 8, and it's all still squared. So x is going to equal, the cube root of 1 is 1, the cube root of 8 is 2, squared. So x has to equal 1/4. And there you go. If you had a graphing calculator, you could have put this into the graphing calculator and hit math. Once you get the answer for this, hit math and then push enter twice, and you'll get 1/4, because then it will express it as a fraction. Okay? All right, and that's going to do it for test 5. So you should be ready to go. You should be good to go. If you have any questions, comments, you can reach out to me and I will definitely respond to you. Do well on test 5. I'm quite sure you will do well on test 5. Continue to social distance yourself. Continue to stay home. Continue to wash your hands. Stay away from your face, nose, and eyes, those areas there. And whatever you do, like we always say, no matter what's going on, you must stay positive. Okay? See you next time.